Okay, look. The idea is really simple. The idea is really simple. Here I have x growing towards infinity. Here I have values of x that are growing towards negative infinity. Do you see that? The notation here looks a little funny because I made it in Excel, so I couldn't really make the formatting very nice. So e to the x, this is supposed to be e to the x squared. Doesn't really look like it, but go with it. E to the negative x, x squared, x cubed, ln of x squared. Notice, exponential functions grow very, very rapidly. The letter e is really just the number, approximately 2.7. So e to the first is 2.7. But e to the 10th, like x is only 10, e to the 10th is already 22,000. 10 squared is 100. E to the 100 is already basically a number that is 43 decimals long, like digits long before you ever get to the decimal point, roughly. 43. Think about this. A billion is, let's pay extra credit. Raise your hand. How many digits does it take to write a billion? Hands, come on. How many digits does it take to write a billion? I'll pay everybody. How many digits to write a billion? 1 billion is how many digits? Stockton? 10. How many knew it? 2, 3 for Stockton. Look at me. This number, roughly 43 digits long, that's e to the 100th power. That's how fast exponentials grow. Look at, now here's different. Look, if you make the exponent negative, the exact opposite occurs with an exponential. It grows towards 0 very fast. E to the negative 100th power is already a number that would be like point and then roughly 44 zeros and then some decimals. That's how small the value has become, e to the negative 100. Questions? Power functions grow as well. They just don't grow nearly as fast. Log functions grow, but they grow very slowly. Check out this. Excel could calculate e to the 100. It could not calculate e to the 1,000. It just says, I give up. So that's why these all are error messages. It won't do it. The computer can't do it. The number's too big. Logs, though, the natural log of 1 million is the whopping number 27. Okay? So you must memorize the pattern of growth. Also memorize that natural log of 0 is unknown, undefined. Natural log of any negative number is undefined, so there's nothing here. Here I'm squaring the log, so that ends up being the same as this one. Questions? Please.
Sorry, can I hurry and take this up?
Yeah, go ahead, Ken. Okay. Let's go to number. Start working on the homework. Go to number 4, please. Okay, look at me again. Again, as I emphasized before, you won't succeed in calculus by just copying what I do. If you could, there'd be no reason to come to class. Like I would have made videos years ago of every problem, and kids would just stay home and watch the videos. But it doesn't work. You have to interact. So I'm going to ask a bunch of questions, and I just want to see how many people understand. So put a box around that. Raise your hand, I'll pay everybody. Who knows what that's for? Please note that Georgia and Andrew were after school. Oh, and Ainsley as well. Nice. They were all after school yesterday. It's perfect. Ainsley, stop.
Oh, why? To find what?
It's to find the y. Everybody look at me. 3 for the 3 of you. Okay, you can't forget that. I'm going to ask it over and I'm going to ask it over and over again. You see a formula, your brain should immediately say, oh, I know what that's for. There's an infinite list of xy pairs. I use that to find any of them. Okay, it's actually to find both, the x or the y. Right now we're using it to find the y. We will use it to find x. So I show you a formula you have to be able to know right away. That's for finding the xy pairs. Okay? Now, it says limit as x approaches infinity. What that means is we don't have a specific x we're thinking about. We're thinking of a pattern. Something like this. X is growing. And x grows forever. And we want to figure out what y does. That's what the question is asking. As x grows forever, what happens to y? Who's it for? Raise your hand, Cameron. Thank you. Questions here. This is what we're trying to accomplish. Okay? So come over here, and I remember that if x is growing towards infinity, oh, here's a good comment. You know, theoretically, actually, if you have a calculator, you can solve this instantly. I can't snap anymore because I broke my hand. Seriously, I told you that, right? Yeah. It doesn't snap anymore very hard. Anyway, yeah, the fingers don't spread either. Look at the, you see? Yeah, don't break your hand. Don't break you, bro. Okay. Look, if you have a calculator, listen, I'm so distracted. Okay, look. Yeah, there. Stop. Focus. If you have a calculator, you can answer the question very quickly. If you plug in 1,000,000, it'll give you the answer. That's all you gotta do, plug it in. The only reason we have all these methods is because without a calculator, you tend to make mistakes if you don't go through a little bit of a process. So our process is x is approaching infinity. I want to compare terms that are adding. So one person, raise your hand, I'll pay you. Tell me 2 terms that are adding that I can compare. Cameron.
The 10e to the negative x, and the 5e to the negative x.
3 tallies. Look at me, everybody. Want to make sure everyone gets really comfortable again making mistakes in this class. Making a mistake, there's nothing wrong with making a mistake, okay? Kevin's like, oh, great. Look at me. You want to get good at making mistakes. I promise it'll make a huge difference. If you make a mistake, who cares? As long as we find out why. So you pointed out 2 terms, but we can't compare them. Why can we not compare them? Ken?
Because they're not being added together.
Because they're not adding. Yeah.
Oh, wait, now I get it.
Does that make sense? No, it's perfect. You good?
Yeah, so then do you compare to the 6?
There we go.
Oh.
So we want to compare these 2.
I just skipped the 6.
Don't worry. 3 for Andrea, 3 for Cameron. So we're going to compare those 2 terms. We're going to think of x getting bigger and bigger and bigger and say, which of those 2 is dominant? Hands up. Who knows? Hands. Come on. Think of the chart I just showed you. Which of those 2 dominates? Zach Fowler.
Was it the 10e to the negative x? Or wait, no, it's the 6.
So which one?
6.
So we saw in this chart that, now you have to think here a minute. I don't have on the chart e to the negative x, because that's the AP test. They don't give you everything. You got to think about it. But if I think here it'll work, because all I have is e to the negative x, so my exponent's always negative and growing, and I'm headed towards 0 very fast. E to the negative 100 is already some decimal that has 44 leading zeros roughly. So right here, the dominant term is 6 for sure. As x gets bigger and bigger and bigger, 6 will completely dominate.
Sorry,
maybe I'm reading the chart wrong, but I think you do have e to the negative x
Yeah.
on the chart, just on another place. Not that that really matters, but I just wanted to make sure that
Oh, you're
was the
good.
same thing.
Oh, you're right, I forgot.
Yeah,
No, I
I just
totally
want to make
forgot.
sure those are the same thing right there.
Thank you, yeah, for sure, thank you. No, totally missed that, Thomas, I forgot I'd done that. And it does show exactly what we're saying, is you can think of it as x, going to infinity. And here we have e to the negative x. But of course, the same thing would happen if we had e to the x going to negative infinity.
Yeah, okay. I just wanna make sure
Perfect,
that's
3
the same.
talents, thank you. Anybody else? Solid. So the 6 is dominant. Don't forget to write equal. We don't really have to write limit anymore. We figured it out. The top's going towards 6. The bottom's going towards 2. Last time I checked, 6 divided by 2 is 3. Okay, I want everyone to answer this one. I'll pay tallies. What does the 3 represent? Gotta know. What is the 3 representing? What does it mean? Claire?
As x is approaching infinity, y is approaching 3.
Perfect, 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 perfect. So my little table here, I don't know exactly how fast it happens. It happens pretty fast because of the nature of the exponential. But this column's going to start looking a lot like 3. How many knew it? 2, 3 for question. Okay, don't forget that in the homework you're also asked to find horizontal asymptotes. So raise your hand if you can answer this. Have we found any horizontal asymptotes yet, or do we need to do some more work? Hence, have we found any horizontal asymptotes yet, or do we need to do more work before I can declare that I've found a horizontal asymptote? Jake Lee.
Well, we've already found 3, so
Perfect.
we need to do it for negative infinity.
Perfect, perfect, perfect. We've already found a horizontal asymptote. That's what horizontal asymptote means. As x approaches infinity, y is approaching 3. I can write that down. So there's for sure a horizontal asymptote at y equal 3. 3 tallies for Jake. Who else had their hand up anew? Show me, show me. I gotta see how we're doing. 2 more, cool. So now we gotta do this one. Let's go find the limit. As x approaches negative infinity, so what do? Show your hands. It's all about the hands. It's how I judge whether the class is following me or not. Let's go to Charlie.
Find which one will grow the most.
We compare the terms, identify which is dominant. So which 2 terms do you want to compare, Charlie?
10 e to the power negative x.
Say it louder.
10 e to the power negative x.
Compared to
6.
perfect. Comparing the terms that are adding. Got my plus sign. Hands up if you knew we were going to do that. Show 2, 3 for Charlie. We've got to back that down next week to 2 and 1, otherwise I give away way too many tickets. No, I keep there. Students never complain about that. But then on the bottom, same thing. So as x is growing to negative infinity, hands up, what's dominant in the numerator? Right? Let's go, Allie.
6.
Say it louder.
6.
The 6. How many, raise your hand please, how many knew that it was the 6 that's dominant in the numerator? Give yourself 2, 3 for Allie. That means half the class thought something else. So hands, what's your other thought? What's dominant in the numerator? I guess the other vote would be the 10 e to the negative x. That was a dumb way to ask a question, sorry. Yeah, they fool you. They're going to trick you. Look, the x is going negatively. So when you have something like 10 e to the negative x, that's negative 1 times the x. But you're plugging into this like negative 100. And and then you're going to plug in negative 1,000, on and on and on. The two negatives multiply, you get a positive. So 10 e to the negative x, as x becomes increasingly negative, actually is exploding. It's like growing immensely. Like I can't even, I have a hard time articulating, okay? It's back to the table. So the dominant term is actually the 10 e to the negative x. Okay, look. Go. You don't have to show the whole world. Go like this if you need me to talk more about that. Like if that's just not feeling solid, let's talk some more. Okay. A few people did this, so I need you just kind of nodding or something so I can see if it's making sense. Are you comfortable that in this problem right here, when I say x is approaching negative infinity, we're doing something like this? Does that feel good? Cool. What we have here, though, is this expression, 10 e to the negative x. But negative x really means negative 1 multiplied by x. And so we are going to replace x with each of these values. So that's what I was doing here. I need to spread my parentheses a little bit more. Something like that. So what happens is the two negatives multiply, and it becomes e to the positive a billion, and e to a positive number, like we showed here, we're following this pattern, where e to a very large positive just grows immensely. Does that help? Cool. Anybody else? So the dominant term, I always say things like, welcome to the AP test. This is what they love to do to you. They just throw in some little twist that forces you to switch off autopilot and just make sure you're thinking. So this is going to be the limit as x approaches negative infinity. And again, if you don't feel like you're getting, look, key is this, you got to understand the why. If stuff isn't making sense, you're doing the homework, like, I'm not sure this is really making sense, just come do your homework here. Like you can stay after school for 2 hours and just work on your homework. I'm here to help you. Promise it's worth coming. So now I have this. Questions to that point? Okay. Let me erase some stuff here. Okay, question for the whole room here in a second. We're just working on really important big ideas. Also working on making the pen work. Okay, big idea again. Just giving away extra credit. Raise your hand, please. Tell me what's the purpose of that purple formula. Pens, come on. It's going to get old, but you got to be good at it. I got to get so everyone's just like raising their hand instantly. Let's go, Carson.
Find the x and y.
It's how I find all the XY pairs. Please raise your hand if you were prepared to say that a minute ago. 2, 3 for Carson. This one here. That purple and that maroon are different. Okay? What's the difference between the purple and the maroon? Hands. Go, Nick Johnson.
Is the maroons only for infinity?
Nice. And actually negative, but you're fine.
Yeah.
Yeah. The purple will work for any x. The maroon only works for x being infinitely large negatively. Show me your hands if you knew it. 2, 3 for Nick. Look at me again, come on. This is the key to the class. Got to get really good at these why questions. Like, what does this mean? What's it for? That's what's going to lead to success, not just copying my steps, okay? So we know this is to find any xy pair. This is to find any xy pair as long as the x is very, very negative. Please, teacher.
Wait, so the purple one could find any xy pair even if it's negative, or does it have to be positive?
Perfect. They gave you a formula, which means the formula can be used to find any xy pair.
Even though it says limit x going to positive infinity?
Keep talking with it, TJ. You are doing perfect. So when you look at this, you kind of have to look at the two pieces separately. It's perfect. The purple is just the formula. I can use it to find any xy pair.
Positive or negative?
Positive or negative. As soon as they slap that limit on there, they're telling you what they want. They want you to only focus on x growing positively. And then figure out, what happens to y as x grows positively. That doesn't change the fact that the formula works for anything.
So, how come the maroon one couldn't, if it did say limit x to positive infinity, could it solve for positive infinity, or why can that one only solve for negative?
3 more tallies for TJ. You are asking all the right questions. Just keep going. You're getting me a little excited. No, it's perfect. Sorry, I have to calm down. Serious. Okay, let me restate it. So the purple one, any xy pair. As soon as they put the limit there, they're just telling you what x they want you to use. Then what we did is we said, okay, we're going to do a new problem. So again, notice here, this box here is the same formulas that we started with, right, TJ?
Yeah.
Good. New limit, though.
Yeah.
But you still think of them separately. This formula, any xy pair. Now they want you to go figure out what happens as x becomes very negative. So we're thinking this. So that allowed us to make our comparison and say, okay, if x is going to become very negative, when these two terms add, this one will dominate. So we get a new formula. That formula is only valid for x becoming very negative because how we created the formula. Did you hear that? Does that make sense? 3 more, please. Thomas.
We'll start with the notation. You put the equals 3 up top, right? So that's our first answer for the problem. But then when it comes to finding the horizontal asymptotes and you move down to that new problem, does the arrow just mean that you started a new problem? Like, is that correct notation for the
Gotcha.
for the test?
The arrow was just me kind of pointing as I talk at the board.
Is it fine if we just keep writing equals even though it's a new problem, or do we start?
Oh, outstanding.
Yeah, that's so I just like I don't want the graders to the test to get lost. Like, oh, what is he even doing? Like, this isn't equal to the last problem.
Gotcha.
You know,
The way I've written it is actually fine because what I'm showing is, look, pay attention where the equal signs are. It gives me this. I say this limit is equal to 3. And then there's no equal sign here, so I'm like starting over. So I write a new statement here. I'm going to find this limit. Notice where the equal is, right there.
Okay.
You see it?
Yeah.
So this becomes equal to this.
Okay, great.
You good?
Yep.
3 more. Any other question? Claire, please.
So does this mean that there's going to be 2 A's?
Possibly. We're searching to find out. Like in the homework, the pink homework, we were always dealing with rational power functions. So the horizontal asymptote over here at positive infinity compared to the one at negative was always the same. Tonight, there are some that have different. 3 more, please.
You have to write the horizontal asymptote at y equals 3, or do you write it as horizontal asymptote equals 3?
Oh, I honestly don't know for certain, but I know what I prefer. I prefer that you write y equal 3, so you don't lose track that we're talking about a line y equal 3 versus x. Good question. 3. Anybody else? Okay, look here. Come on, look. So this formula now is for finding any xy pair as long as x is extremely negative. Nod if that makes sense. Nodding. Thank you. Good. So I'm here. Another huge idea. Okay, this right here in brown is something you must always recognize and know what you're looking at. It's why I separated it. Hands up if you know what that equals. Come on, show me your hand. Don't say it. Emily, Ferguson. How many agree that that's 1? 2, 3 for Emily. You always have to watch out for exceptions. That's how they get you. Show me your hands. Is there any x that we plug in that will make that not equal 1? Man, is there any x that we can plug in that will make that not equal 1? John?
0?
0 is what, okay, so just letting you know, 0 is incorrect. We don't care. Mistakes don't matter, right? Just got to know why. How many thought it was 0? Show me. 2, 3 for Jonah. See, I pay for mistakes as well as right answers. It doesn't matter. It really doesn't. The whole idea is that you're willing to think about it and just keep thinking, keep thinking, keep thinking, keep straightening it out. So 0 is what most people think, but it is wrong. Here's why. But, sorry, I'm getting so excited. Can't breathe in the stupid mask when I get all excited. Look, e to the negative. You plug in a 0. Okay, you need to memorize this. E is about 2.7. There's no such thing as negative 0, it's just 0. E to the 0 is what? So really, we get 1 over 1, which is still 1. Okay? So there actually is no x that will make that anything other than 1. There's no exception to this. Always 1. Question. Awesome. So now I know. This is my formula for finding the x and y pair when x is very, very negative. But if that's always 1, then the answer to this is 2. So as x approaches negative infinity, y is approaching 2. So as Claire said, 2 different horizontal asymptotes. Like that. Question. Please.
Wait, so is this like gonna be part of our homework, or is this just something extra you want to say?
Gotcha. No, I do this quite a bit. I made enough homework problems I could use some of them as examples. It saves having like another packet of notes or something. So that's problem 4 from the homework. And that's completely finished now. We found the limit they asked for. We checked for a horizontal asymptote at positive x equal positive infinity and x heading towards negative infinity, so we're done. Does that make sense, Cameron?
Yeah.
3 more.
How is e to the 0 not here?
Topic for another day. Memorize it for now. Yeah, any number other than 0 to the 0 power is always 1. So yeah, apologize, I don't have time yet, but we can talk later. I'll have to look it up, I don't remember. Mr. Rucky probably knows, I don't remember. So. We'll talk another day. Okay. Anybody else? Cool. Next example. Go to number 8. Okay, I've already hammered this really hard, so I don't want to get too annoying. That's for finding the xy pair, okay? Okay, try to get the right balance between annoying and make sure you know it. So that's for finding the xy pairs. Something to pay attention to. A is a constant on the AP test, unless stated otherwise. So A is not, see, x is different. X is every value from negative infinity to positive infinity. So x is a variable. A is a constant. We just don't know the value of the constant. Please, John. What's that? Oh, it just means A has a value of like 7. They're just not telling you. Or perhaps A has a value of negative 3.5. That's all I need. Does that make sense? Yeah. What are you telling me? 3 points. There you go. I gotta stop saying tallies. tallies takes 2 syllables, point takes 1. So I'm going to start saying point now. Okay, cool. Saves energy. You get here? But tally and point mean the same thing. Or we got no. Okay. So we good on A as a constant. Awesome. So when it says x is approaching A, that's not infinity. It's some number. We don't know the number, but it's some value. But because it is not approaching infinity, I cannot make a comparison between terms that act. Skip that. Second thing we learned is that I want to look to factor. So, oh, by the way, it's one of the favorite things for them to do on the AP test. All they have to do is create a problem that has a few few things like A in it, and half the world freaks out. But there's no numbers. Well, no, there are. But they behave this anyway. Never mind. Okay. So I factor. So let's take out the 10. Don't forget to write equal, like Thomas pointed out. Ah, shoot, 4, my bad. Fix that. Take out the 5 on the bottom. Question? Okay, points available here for the whole room. Okay, this is a trick question. When I say that, what I mean is, when I ask the question, if you're thinking, oh, that's a trick, then you understand. What's the difference between the purple and the red? Trick question. Like before, we would do this. I'd say, okay, look, we were doing this problem back here, and I said, what's the difference between the purple and the maroon here? And we talked about it. I want to do the same thing here. But it's a trick question. What's the difference between, show me your hands, purple and red. Hand. What's the difference between purple and red in this case? Let's go, Luke.
They're the
Arnold.
same.
Say it again.
Aren't they the same?
How many knew it? 2, 3 for Luke. No difference whatsoever. Because all we've done is factor. We did not make some sort of comparison of terms and then throw away the one that's negligible. We just factor. When you factor, same exact thing, just looks different.
Is factoring necessary or does it make it easier?
Oh, awesome. It's probably hard to see because of the glare, but this sign here by Amanda Lindstrom says, if you forget to factor, you fail. Yeah, AP test, you don't have to factor every time, but on limit questions where factoring is possible, 99% chance if you don't, you'll get in trouble. Like you'll not be able to figure it out.
Okay.
Yeah. It's not just making it easier, it's actually you can't see it without factoring. So, good question. 3 for Kayla. Okay, but remember that what we learned last time, we are factoring so we can divide. Oh, yeah, thank you.
Mr. Smithson.
Oh, wait, Nate, anxiously for the news here.
Riker or Ross Kelly?
Okay.
Give them that. Riker, Ross Kelly to the front office.
All right.
Yesterday.
Police are waiting. So. Someday when you have a little more time, I'll tell you that story as well. So. Oh no, it's a good story. It's not as good as Mr. Recky's prom story, but it's a good story. Oh, yeah. The prom story is legendary. Mine's just a story. Mine's just a little story. Anyway, look up, look up, look up. Come on. Okay, so remember. Make sure your masks are on, please. Yeah, it's normal. They pull down when you start talking. Just make sure they're on. Look, no, my neighbor actually has COVID-19. It's like he's kind of my age. Like he's really struggling. Like, he hasn't had to go to the hospital, but it's miserable. So I really appreciate your help. It really helps me. So. All right, look, we only want to factor if we can divide. So I keep going. Now we have the limit, x approaching a. This is 10 over 5. Difference of squares here. And I like writing out the fractions because it just makes it easy for everyone to see what's going on. And sure enough, I end up with factors that can divide. When you write fractions next to each other, that means multiply, so you don't really need the dots. Those are redundant. So, question? Cool. Oh, please, Ainsley.
Oh, wait, why is it x squared plus a squared on the right?
Over here.
Yeah.
So whenever you're factoring a difference, like two things that are subtracting, you always take the square root of this. So the square root of x to the 4th is x squared. And then it's minus the square root of this,
Okay.
and then just the opposite. Is that okay?
Yeah.
Retell. Please.
Wait, you don't always have
Uh-huh.
it.
Don't worry, Emily. So whenever you're factoring the difference of squares, like you've got something minus something, to factor, all you have to do is take the square root of the first, so that's x squared, square root of the other, that's a squared, put minus, and then repeat the pattern just plus. So you can memorize that. It always works. 3 more. Okay. Whole question for the whole room again. Giving away points. Hands up. What's that equal? Come on. What does that equal? Savannah Carroll. How many agree? 2, 3 for Savannah. Are there any exceptions? Are there any values for x? Come on. Are there any values for x? When you plug into that, you do not get 1. Are there any exceptions? Plug in some value for x, and you don't get 1. Got to watch out for the exceptions. Thomas.
I'm going to say it's 0.
Let's
Because it's
try
not
it.
an exponent this time, so it's like 0 to the 2nd power.
Stay with me. Let's just try it. You're doing great. You really are. 3 for Thomas. Look. 0 squared is? 0 squared is?
0.
0. Squared means 0 times 0. Got you all mixed up now. 0 squared is 0. Minus a squared would just be negative a squared.
Oh, okay.
And then the bottom would be the same.
Sorry, never mind.
No worries. So negative a squared divided by negative a squared will be 1, as long as a isn't 0 itself. Everybody with me? There is an exception, though. There's something I can plug in that will make this not Luke, please.
Is it whenever x squared will equal a squared?
There you go. Wait, what?
Let's think of that.
So if you plug in an a for x, watch, come on, focus. You plug in it, there we go. You plug in an a for x, you're going to get a squared minus a squared, which is 0. 0 over 0 is undefined. There we go. With me? 3 for Luke? Yeah, feels good, huh? Look. Hands up, come on. This is the key to the class. The key is not the steps. The key is making sense of the ideas. So, does that matter? Yes or no? Hands, come on. Hands, does it matter? Is the exception important? Yes, no, or why not? Hands. Come on.
I don't know.
I don't know his curve. 3 points for TJ. Go.
I don't know.
It goes
Go. You gotta be the first one. Go.
It goes to A, but it's never gonna hit A, so it doesn't matter.
Yeah! Notice I didn't use my fist. Sorry, keep me all wound up. Keep me all wound up. Yes. Listen to Jacob. Listen to Jacob. What? Okay, listen. It's perfect. He's keeping track of what he's doing. He's not just doing steps blindly. He says, okay, I get that I factored. Perfect. You know, I factored. This is 1. Wait a minute. It could be an exception. Oh, don't care. Because I'm finding the limit as x gets close to a. I'm not trying to figure out what happens when x is a. So the exception doesn't matter.
Will there ever be exceptions that do matter?
What they usually do here to trick you is this. Sorry, that hurt. Here's what they usually do to cause you to make an error. We're not looking for this. We're doing a limit. So we're looking at these two, correct? So the exception doesn't matter. We can just keep going. But then, you know, they might ask you to figure out this. I'm not, but they might. So hands up, come on. What is f of a? Hands. What is f of a? Come on. What is f of a? Janessa?
Would it just be like the exception to that?
It is.
Okay.
So if I plug in exactly a, what does this become, Janessa? Undefined. Because you get 0 over 0. So this is undefined. Jacob, that's usually how they're trying to fool people. Is you're working on the limit, you kind of forget about this, and then they go and ask this, and you forget. Does that make sense? Okay, so I got all wound up. Other questions? Please.
Is A like a Y or an X value, or is it just like a number?
Just like a number.
Okay.
Yep. Please.
Will you just go over the undefined thing again?
Mhm. No, keep asking, Georgia. 3 tallies.
So
3
like,
points.
I know what f of a, so that's like the y, correct?
Mhm.
And then, but like, why would that be undefined?
So the reason the y coordinate is undefined, which, you know, from a common sense perspective just means we don't know, is if I plug into this formula an x value that is equal to a, this will become a squared.
Yeah.
And you tell me what's a squared minus a squared?
Yeah.
Good. A squared minus a squared?
Yeah.
Also 0.
Oh,
Just memorize for now. 0 divided by 0 is unknown. We don't know.
okay.
Does that answer your question?
Yeah. Fine.
Perfect.
Thank you.
3 points, please.
So since it's x approaches a, x will never equal a.
Correct.
Okay.
Yeah, that's, hey, it's back to what TJ was doing a good job of earlier. The formula has nothing to do with the limit. The formula is just a formula for finding all the xy pairs. But as soon as they say limit as x approaches a, it's their way of asking you to figure out, for these 2 x coordinates, what is the y? But not for that one. Please.
So will we ever be asked on a question like this if the limit x going to infinity or negative infinity, and will that change it?
Absolutely. Stay with me. We've got 2 minutes. 3 for Zach. So look here. Okay. So if we're finding the limit, this is 1. This is 2. So I get this. Okay? Hands up, come on. What's the purpose of that maroon box? What's the purpose of the maroon box? Timmy?
So find the xy pairs as x approaches.
Perfect. And we can actually expand it a little bit. The maroon box, look at me, everybody, we're running out of time. The maroon box will find every xy pair except for 1. The exception.
When A.
Yep. So it works for everything still, just not that 1x. So that's even more useful. It's like, oh, that works for all kinds of xy pairs except for one of them. But we're good because we're not looking for that one. So we just plug in close to a. Close to a squared will be close to a squared. Close to a squared plus a squared is going to be close to 2a squared. Times 2, the answer is 4a squared. So this y coordinate is getting really close to 4a squared. This y coordinate is getting really close to 4a squared. That's the value of the limit. Question? Oh, please.
Can we do that again?
Yep. So we're going to plug into x, close to a. Positive, negative. Okay, if I plug in exactly a and square it, I'm going to get exactly a squared. 1a squared plus another a squared would be 2a squared. Times that 2 gives me 4a squared. Do you see it now? Good question. Good question. Please.
So what's the difference then between that green box, and the maroon box?
So the green box is equal to 1. Because it's not the whole formula. And we said if that's always equal to 1, we don't have to include it here. Because 2 times 1 times that would just be that. Please.
Only plugging a number, we're not plugging in a squared.
Right, we're plugging it in x. Because it's right here. x is becoming a. Make sense? So I'm actually going to, okay, so we found the limit as x approached, oh, number 8, sorry, my bad. Go with the right one. Okay, so we found the limit as x approaches a. Are you with me? Okay, for the horizontal, so this part's done. For the horizontal asymptotes, we need to go find the limit as x approaches positive and negative infinity. We can take a bit of a shortcut because we're dealing with a power function in the numerator and power functions in the denominator. Therefore, the asymptote will be the same on both sides. That's only true if you have numerator comprised only of power functions, same for the denominator. You gotta be careful with that little trick. So I'm gonna write it down. I'm gonna go find the limit as x approaches infinity of that thing. And now you're starting over. Like you, oh, I have a, ooh, let's do a shortcut. Better idea, sorry, better idea. This is why I keep asking this in class, like, what's the purpose of this formula? What's the purpose of this one? So remind me again, what's the purpose of the maroon?
Same.
Same, except for one exception. There's an exception for the maroon. What is it? No, say it. I heard you say it.
Negative.
No, like the purpose of the purple is to find any xy pair. The purpose of the red is to find any xy pair. The purpose of the red is to find any xy pair except a. But we're not trying to find what happens when x equals a. We're trying to find out what happens when x goes to infinity. So this formula is perfectly fine. Right?
Yeah.
So if x grows and grows and grows, what's y going to do? Grow and grow and grow. So I can quit. I can just write down the answer. Like there's nothing really that I have to work out. They both grow. Right, because again, think of it this way, Maddie. This is our formula.
Yeah.
You've got your list of xy pairs. X is doing something like this. Forever. Well, if we're plugging this into this formula to find y, it's just going to grow with it.
Okay.
So now I can say, as x approaches infinity, y does also. That's not a horizontal asymptote.
Okay. So do you have to plug in negative infinity, or does it not?
No, we do.
Okay.
So if you plug in larger and larger negative numbers here,
Yeah.
but then you square them, they become positive.
Oh, also 10.
Does that make sense?
Yeah.
Good morning, night, and happy Friday. This is Taylor.
You're very welcome.
And with